Stop, Michael, I can't balance this thing.
Hang on 2 seconds. Anyway, you shouldn't try doing it like that when it's still.
Well, how am I supposed to balance it?
Try pedaling. It's much easier when it's rolling.
Why is that?
Well, an object that has circular motion resists tilting over, so it's easier to stay upright and balanced.
I don't get it.
Well, come on, ride beside me and I'll show you how it works. Come on.
All right, cool.
Wait, hey!
Why is it hard to balance a bicycle when you are still? What helps keep unstable objects balanced? How do speed and friction affect balance? Let's find out.
Hey everybody! Welcome back to Moon Kong Simple Science. Have you ever tried to stay balanced on a bike when it's not moving? It's really hard, right? Well, it's a lot easier to stay balanced on a bike when the wheels are moving. Now this happens because rotating objects help to give us balance. And we are going to look at that in some experiments today. Okay, so before we start, let's take a quick look in front of us. So what you see is we have a homemade top with a point on the bottom that the top can rotate around. So in the first experiment, let's see what happens when we don't rotate the top and try to make it balanced. Here we go. Okay, let's try one more time. Okay, so what you notice is the top falls over. Now, unstable objects such as this top are very hard to balance when they're not moving or moving slowly. They tend to fall over under the force of gravity. Okay, now what do you think will happen when we give this top some circular motion by rotating it? Let's take a look. Okay, so what you notice is that by rotating the top, we cause it to keep its balance on its point. Now this happens because objects in motion tend to want to stay in motion. When we give the top circular motion, it tends to want to keep turning in this direction. So as a result, it resists tilting over and falling under the force of gravity. It stays balanced. Okay, now in your second experiment, let's see how the speed of rotation affects the balance of an object. So again, let's take our top and let's turn it very slowly this time and see what happens. Okay, it fell over pretty quickly. Now let's give it a try, but spin it a little faster. What do you think will happen this time? Let's find out. Okay, so what did you notice? Well, you see that as we spun the top faster, it was able to keep its balance for a lot longer. By increasing the rate of circular motion, we've increased the duration of an object's stability. So as a result, the faster spinning top can keep its balance because it can resist falling over a lot more than the slower moving top. Okay, so let's move on to your third experiment. Now in this experiment, let's take a look at how friction between the rotating object and a surface affects its balance. So for this experiment, let's use a towel to give us a little more friction than the table did in the first two experiments. So what do you think will happen when we try to spin this top on the towel with more friction? Let's find out. Okay, so what you notice is that when we spun the top on the towel, it slowed down a lot quicker and lost its balance a lot sooner than it did on the table. Now, because we're using the towel, we've increased the friction between the top and the towel. So as a result, the circular motion slows down a lot quicker and the top loses its balance and falls over a lot sooner than it did when we rotated it on the table. Okay, so let's review what you've learned today. Now, unstable objects are difficult to balance when they are not moving or moving slowly. Circular motion helps unstable objects stay balanced and upright. Increasing circular motion increases stability and balance. Now, increasing friction decreases the duration of an object's balance. Well, that's all the time we have for today. So next time you're on your bike, remember how the rolling tires are keeping you upright. I'll see you next time. Goodbye.